At some point in the past, you've probably found yourself in a situation where you have to make a decision without an obvious best option. There might have been two or more fairly equal choices to consider, or maybe there were so many things to consider about each option that it was hard to decide between them. This sort of thing happens in engineering applications quite often, and when it does, one commonly used method for making a choice is a decision matrix. Among other things, it is often used during the engineering design process when considering alternatives. And while it does involve some basic math, this technique can help with decision making when there's no clear choice, or when a large number of factors need to be considered. Even in cases where the options are very closely tied, the decision matrix can help to eliminate options that aren't comparable to others. And if you use a spreadsheet program, there will be even less math required. There are some limitations to the decision matrix, though. While it is very useful for evaluating options and showing some grounds for your decision, it does take a fair amount of time to use, so it's less suited to decisions that need to be made on the spot or very quickly. It can also be considered overkill for simpler decisions, where calculating the costs and benefit of each choice might be unnecessary for the scale of the decision. Also, while it does remove some subjectivity from the final decision, it is not a completely objective decision-making tool. It is also possible the decision matrix might not indicate that one choice is clearly the best, but even in cases where the options are very closely tied, it can help to eliminate options that aren't comparable to others. There are ways to reduce subjectivity further with additional math, but to keep things simple, I'll just be focusing on the base method to avoid going overboard in the mathematical requirements. In my experience, I found it effective to learn from examples, so here I'll be using the decision matrix to make some example decisions. It's worth noting that there are multiple variations of this technique and other ways to use it, so I'll just be showing how I learned it and the way I use it in my applications. Alright, so for this first example, I'm going to be using the decision matrix to decide between three apartments. They are located at Tennessee Avenue, Indiana Avenue, and Atlantic Avenue. And you see here I have the framework of the decision matrix set up, but I haven't filled in any of the values yet. So we start with our factors and weights. So the factors are going to be the aspects of your options that you're considering. There can be any number of factors, but you generally want to have them as independent as possible. So for factors in choosing an apartment, we have costs, location, building quality, utilities, and we'll say neighbors. Now for each of these factors, we're going to assign weights, which in this case is an importance out of 10, or you can do a decimal value if you prefer, but just to keep things simple, I'll just do a score out of 10. And this score indicates how important each of these factors is to your decision. So in this case, if your decision was primarily going to be influenced by the cost of the apartment, you could put a 10 for the score here. If then location, it's important, but not the primary concern, we'll give it a 7. And let's also do the same for building quality. And then 6 for utilities and 4 for neighbors. Now, before we continue, it's important to note that it will simplify things if you put all of the factors in terms of higher values being better. So in the instance of costs, we want to define this as low costs. That way, a higher value means lower costs. And here's where a little bit of the subjectivity comes into play in this method. These weights are assigned based on your personal considerations of the importance of each of these factors. So, though there might be some mathematical means of selecting a score for each of these weights, in situations like this, you might just need to come up with something on your own. So there is still some personal subjectivity involved, but this does at least eliminate some of that. So then once we have our factors and our weights decided, we can go in and score each of the options in each of these factors. And we'll be scoring them out of 10 again for consistency. So let's say that Tennessee Avenue scores a 7 out of 10 for costs. And then we'll give it a 6 for location, 6 for build quality, 8 for utilities, and 5 for neighbors. And just like when we were coming up with weights for each of the factors, when you're scoring each of the options, this is also a subjective part of this process, where you just have to put in what your opinion is for this option. So it's not completely objective once again, but this does allow you to put a number on your opinion and give it a bit more of a mathematical basis. So then we can go in and score the other options. All right, so once we have a score assigned for each option and each factor, we can go and calculate the products. So this would be multiplying the score that the option received for each factor times the weight of that factor. So in this case, for Tennessee Avenue's score on cost, we would be multiplying 7 by 10. And in a spreadsheet like Google Sheets that I'm using, you can do this simply by pressing equals and then clicking the cell with the score multiplied by the weight. Enter. And then also you can just click and drag this down and it will calculate the scores for the rest of the weights. Then we'll want to do the same thing for the next option, and that will be the same procedure as before. And then if you're using Google Sheets, you might get this autofill to come up, which will be also speed things up a little. And for our last option, all right, so now we've calculated the products for each option based on the weights and factors that we've decided upon. Now we can go in and calculate our final score for each option by adding up the products of our previous scores. So the easiest way to do this is with equals sum, open parentheses, and then just click and drag and hit enter. And then you can go and just drag this over, and there you have our final scores for each of our options. And as you can see, based on these scores, Tennessee Avenue is clearly comes out ahead of the other two. Therefore, that would be our choice based on this decision matrix. All right, so now let's do an example with a bit more of an engineering angle to it. So this one I'll be deciding between several projects to attempt. And we've got the same setup as the previous spreadsheet. And if I'm going to be choosing between one of these three projects to work on next. So for factors to consider when starting a project, we'll say complexity, difficulty, costs in both time and money, feasibility, and usefulness. Now, complexity and difficulty are similar to costs like we did earlier, where we'll have to invert this to make it the focus be on simplicity rather than complexity. Likewise, for difficulty, we'll change this to low difficulty. Also note that complexity and difficulty are technically different in this situation. Also change this to low costs. And of course, depending on the project, there might be other factors to consider here, but for example, we'll go with these for now. Just as a general tip for when you're using a design matrix for something like projects or design alternatives, complexity, difficulty, and feasibility are important factors to consider in those situations. So next, I'll fill in some weights here. We'll say 9, 8, 7, 10, 5. All right, so once I have some weights and some factors, we can go in and score each of the options here. All right, so now that we have scores for each of these projects, we can go in and multiply them like we did before. And then autofill in the rest of the column. There we go. So now we have our scores for each of the options. And then to calculate a final, you go in and sum each column. There we go. And as you can see, the robot arm ends up with the highest final score. So that would be the decision based on the decision matrix. So there we have it. We have a couple examples of how to use the decision matrix. And like I mentioned before too, just keep in mind that this is just one way of making a decision. There are a lot of other ways you can go about this, so don't necessarily rely on this exclusively. Just consider this as another tool that you can use when you're making decisions. So with that, thank you all very much for watching. I hope you enjoyed it. Click like if you did. Leave a comment if you have any questions about anything in the video. I can try to answer some basic questions or give a little bit more information on things. Consider subscribing for more engineering and sci-fi and space related stuff. I don't usually do these in-depth types of videos, but if it's popular, I might look into doing some more. So if there's any other engineering topics you'd like covered, let me know. And thank you again for watching.